Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at modular programming with DLLs. One approach to developing and maintaining large, complex applications is to break the application into a number of smaller, more manageable parts in the form of DLLs. These separate dynamic link libraries allow you to make a change to one library without having to recompile and retest the original executable. As long as the interface has not changed between the main executable and the DLL, then everything should be well. So why would you want to break a perfectly good, large executable up into a number of smaller, dynamic link libraries? If you have a large team or a large number of teams in separate locations, it can make sense to actually spread the work across all of your developers. That way one developer or one team can have the task of developing and maintaining one area of your application. Therefore, when the application needs to be updated, you may only need to release one or two smaller DLLs rather than the full application. So what we're going to look at today is one of the applications we wrote some time ago to do array sorting. At the moment, this is all in one executable. What we're going to do is we're going to break some of the functionality out of this application and put it in a DLL. So first of all, let's have a look to see what the application actually does now. This application uses the main Windows 32 API library, and it also brings in three additional libraries of our own. A common display one to allow us to display things on screen, a file handling routines library to allow us to bring a flat text file into an array, and a sorting library. What we're going to do today then is we're going to take the functionality of this sorting library, and rather than having it as an include in the main application, we're going to create a DLL that has that functionality. In the code, the first thing we do is we load this CSV file. The CSV file is quite small and has a number of names and addresses, telephone numbers and account numbers. And the purpose of this application was to allow us to take this file into an array, sort it and redisplay it on screen. So we're calling this common function to read the file into an array, and this function exists within this library. Having successfully loaded that file into the array, we're then setting some parameters for the column we wish to sort on, the delimiter of the file, the sort type that we're trying to sort, whether it's going to be ascending or descending, and we're calling this function which performs the sort for us, and should anything go awry, it will return an error message in this variable here. So there are 6 parameters to this function. An input and output parameter, which is the pointer to the array itself, a sort type, a field, a delimiter and a sort order. All of these are inputs to this function, and one final parameter which is an output should an error occur. And if this entire function returns true, then we redisplay the array on the screen. So if we run the application now, we will see that the array is brought up on screen and we're sorting on the 5th column, which is the account number column. And we can see the account number column is what we're using to actually sort this array on screen. Now this is a very simple piece of functionality, but we're going to demonstrate how this could be used by moving this logic into a DLL. So how would we actually do that? At the moment we're inside the console compiler, and if we want to create a DLL, we'll need to use the Windows compiler for that. So here we are in the Windows compiler. If we go up to the toolbar, we will create a DLL framework using LibMain. This gives us a blank form onto which we can actually put our code. Now the logic we want to bring in is that which sits inside this sorting include file. So we'll bring that code in as well. So we will give this new file a name. we're going to call this pbsort.dll when it compiles. So we will save that as pbsort. pbsort.bas. Now what we want to do is we want to take the functionality that's in this include file and we'll just paste this in its entirety into our new library. Now in order to turn this into a DLL, there are a couple of changes we'll need to make. At the moment this function is purely internal to the DLL, but we want to be able to access this from outside the DLL. Therefore this function will need to be exported, which we can do by adding the word export at the end of the definition. The other thing we want to do is we want to give it an alias. Internally to the DLL, this is the name of the function. Now, while this is going to be a very simple DLL with a single function inside it, your DLL could contain many functions and subroutines. However, most of them will not have the word export in their definition. Only the ones you wish to expose to the outside world would have the word export. All the rest would purely be internal functions that could be called from this function inside the DLL. So what we're doing is setting up what the definition of the interface is between the main exe and this DLL. So the other thing we'll want to do is to give this an alias. The alias is the name by which this function will be known in the outside world. One thing of note for this alias name is that it is case dependent. Whatever casing you're actually setting up in the name is the casing you will have to do when you call the function from outside. A common problem when calling DLLs is failing to take into account that the casing is vital. So that is the only change we'll actually have to make to this routine. To put the export in before the as long and to give it an alias. All the other parameters will do just nicely. So having saved that, we can now try to compile it. And that's it compiled. If we have a look inside our code folder, we'll see there's now a new file, a pbsort.dll. So that's us compiled our DLL. How do we actually access that from our main code? Well, let's go back to the console compiler. And in here, there are a few more changes we'll need to make. We no longer need to call the sorting include file, because all the logic that performed is going to be done within the DLL. So at the beginning of your code, we're going to have to put a declaration in that tells the main executable what function we're going to call in the DLL and what's the name of the DLL. So we need to declare this function. So it's simply declare function and the name of the function that you will refer to within the executable. Then we have to tell it where this function actually exists. Now we're importing it from the DLL. So we have to name the DLL, and we also have to give the alias, which is the name by which the function is known from within the DLL. And again, as I said, the casing is vital. After that, we then have to, in brackets, give all the parameters that we're expecting to be used within this function. These are exactly as we had them before. So we're doing a declare function, the name of the function within the executable, the word import, the name of the DLL we're importing the function from, and the alias being the name of the function that is exposed in the DLL itself. So now that we have that set up, we can go down to where we called it before. Now in our code we called funArraySort, which is how we've declared it in here. And if that returns a true, we will display on screen. If it returns false, we will give an unable to sort. So if we try to compile that program now, we will see it will compile without a problem, even though all the sorting code is no longer in the exe, it's in the library. So we try running the code now. We'll see it performs exactly as it did before. So we've effectively taken the logic out of the executable and put it into the library. This means if we need to make any change to the logic of the sorting which is happening inside the DLL, we only have to update the DLL itself. As long as we're not changing the interface, the number and type of the parameters we're passing between these two, then the exe itself may never have to change. Doing your development this way will allow you to segment your application, so that each area of functionality could in theory be handled in a separate DLL, and each DLL could be maintained and developed by a separate person or a separate team. So when it comes time to release your application, what you'll need to do is to package up your executable and your DLLs as part of the release package. And for any subsequent update, should the functionality only need to change within 1 or 2 DLLs, then there's no need to release the main executable again. You could just update the DLLs. Another advantage is if you have a number of applications which all use the same functionality, all that functionality could be in a single DLL. And should there need to be an update to what that DLL does, you merely have to recompile the DLL with the changes in, and all the applications would therefore inherit the new functionality by accessing the updated DLL, without having to recompile a number of applications. So this has been a short introduction to modular programming. That's it for today. Thank you for watching.